Hello everyone, I'm John and we are reading Cultural Anthropology, asking questions about humanity. We got some technical issues, so I'm re-recording. Moving beyond purely biological notions of evolution. Even though under Boa's influence the focus on culture over biology became dominant in 20th century anthropology, evolutionary thought never completely disappeared from cultural anthropology. One reason is that it offered one way to address the question of why and how cultures change. For example, between the 1930s and 1950s, cultural anthropologists such as Julian Stewart and Leslie White applied evolutionary theory to explain how and why cultures changed, or the tendency of cultural systems to increase in complexity. In more recent years, several schools of evolutionary thought have emerged with relevance to anthropology, including sociobiology and evolutionary psychology. Both of these have similar goals, so we will consider only one of them: evolutionary psychology here. Evolutionary psychology. Evolutionary psychologists seek to explain contemporary human behavior, cognition, and perception as the outcome of evolutionary processes. For example, they commonly argue that through natural selection, human males evolved to be naturally aggressive and sexually promiscuous. Meanwhile, females evolved to be innately passive, preferring a single mate with ample resources. These arguments are an example of biological determinism, the belief that human behaviors and beliefs are primarily, if not solely, the result of biological characteristics and processes. These seemingly common sense explanations appear to explain why men cannot seem to be loyal to their girlfriends and wives, or why women are attracted to wealthy and powerful men. They have played well in the media, hungry for eye-catching stories. Similar behaviors among primates with whom we share common ancestry are often presented to prove that these conditions are natural. But these claims rest on poor logic and flawed science, including the very use of contemporary primates as evidence for the naturalness of these behaviors. These other primates have also been evolving for a very long time and adapting to circumstances sometimes quite different from the evolutionary conditions that have shaped humans. So we cannot assume that the behaviors we see in them today have any relationship with our common ancestry. In fact, ecological and social variability among primates is so great that it is impossible to identify any meaningful patterns except in most general sense. For example, in 40% of primate species, females actually dominate over males. In addition, while all primates have the capacity for aggressive behavior, the incidence of aggression is not evenly distributed. Researchers studying primates have found that the reproductive success of individuals depends less on aggression than on the ability to get along with others in a social group. Paternity tests on primate species that are not seasonal breeders, i.e., who are capable of breeding at any time of the year like humans, show that dominant and aggressive males do not necessarily have the most productive success. No animal or human carries genes for dominance, aggression, or passivity. The capacity for dominance, aggression, and passivity are complex social and psychological conditions and states that involve biological processes such as the production of certain hormones, but they are not fixed properties or traits carried on genes. Even if they were carried on genes, genes operate in such complex ways there would be no way to ensure that this particular gene would express itself in behavior. It is much more accurate to think of the causes of aggression as coming from social and cultural processes, such as disagreements over land, women, and resources, not some adaptation humans made in a distant evolutionary past. Evolution still matters. None of this is to say that humans are not continuing to evolve as a species with biocultural consequences for individuals. For example, improvements in travel, technology, and social changes promoting mobility have created high rates of global migration. In these processes, the intermixing of human populations is leading to gene flow, an evolutionary process in which genetic material moves between populations and creates change in how people look. The distribution of susceptibility to disease and other biological changes. But it is difficult to accept that culture and cultural change follow the same principles of biological evolution. If only because genes do not transmit culture, people transmit culture from individual to individual. We are not constrained to following the cultural patterns of our parents, but can model our own ways of doing things on patterns we see among our neighbors. The interactions of individuals with each other, culture, economics, politics, and social processes, not to mention nature itself, are much too complex to reduce to biological arguments. Besides, we explore in our final selection who is to say that we as individuals are subject to evolutionary pressures anyways, living in an era in which scientists can manipulate genes? Question mark. Is biotechnology changing our bodies? Not so long ago, the idea that a person could clone himself or herself, that parents could choose the color of their child's eyes, or that scientists could transplant genetic material from another species into our own genes seemed like exotic possibilities. But we hear constantly of the revolution in genetic research that has begun to accomplish such things through biotechnology, which refers to genetic engineering or any other technological modification of biological systems to make useful products. These facts have led some scholars to ponder if humans are no longer adapting to nature, but transforming nature to fit their needs and desires. Singer, 1966. Humans play an active role in biological evolution. For thousands of years, humans have been manipulating the genetic makeup of other organisms to fit their needs and desires through the selective breeding of plants and animals and the modification of natural environments. What is different in the age of biotechnology and genetically modified organisms is that genetic manipulation can occur at the level of specific gene sequences. For example, scientists perform gene therapy by taking out mutated gene sequences linked to disease and inserting new ones. Nobody really knows whether such techniques will be widely available and effective, or what the long-term genetic and ecological consequences of such practices will be. But it must also be said, to date, there have been very few viable examples of medically useful gene therapies. Why? Because genes function in complex ways that scientists are still struggling to understand. In the first section here, we explain why, and in the second section, we explain why that doesn't seem to stop the use of genes to explain all kinds of things going on with humans. How genes work. The basics. DNA consists of pairs of long molecules in the form of a spiral called a double helix. Each strand of DNA contains billions of nucleotide bases that contain a genetic blueprint for all living organisms. These DNA strands are found in the nucleus of every living cell. There are 4 nucleotide bases: adenine, cytosine, guanine, and thymine, and each has specific affinity or chemical attraction to one of the other bases. The rungs of the ladder of DNA are always composed of an A-T or C-G, as in Gale, pair. When the nucleus of a cell divides to create 2 cells, the filaments of DNA separate, and each nucleotide base attracts its mate reproducing exactly the other filament of DNA for the new nucleus. A gene is a long sequence of nucleotides found along a strand of DNA. The gene's primary purpose is to allow the cell to form specific proteins. These proteins are used for communicating with other cells and triggering other bodily processes. Other parts of the genes turn the production of proteins on and off in response to external conditions. Genes are necessary to produce proteins, but so are other things, including the nuclear and cellular machinery that actually makes proteins. So if you want to understand why one person with a gene linked to breast cancer gets the disease and another without the gene does not, you cannot study the offending gene alone. You also have to understand how the particular gene interacts with its environment. Environments that range from the internal biological environment at the nuclear, cellular, and somatic levels to the external, familial, social, and ecological. These interactions include everything from whether the machinery to produce proteins is in good shape to whether there are certain triggers present, such as an individual's dietary patterns, or the presence of a toxin in his or her environment. Scientists are just beginning to explore gene-environment interactions. The bottom line is that genes never work in isolation, and they do not cause anything by themselves. Herein lies a central flaw of using genetic explanations for almost anything having to do with people. Genes are just one agent in a very complex processes that makes us human, causes our maladies, makes us intelligent, and so on. Expecting the revolution in genetics to solve human problems by decoding our individual gene sequence is unreasonable, not because genetics will not identify most of our genes, but because what triggers genes to act is largely not coded in our DNA. If we think back to the situation we opened this chapter with regarding genetic testing for a propensity to get carpal tunnel syndrome, it is clear the repetitive work of data entry at keyboard or some similar repetitive task in the workplace was the likely precipitating cause. But even if some people had a propensity to get carpal tunnel syndrome, it is unlikely that these genes would be triggered without the environmental stimulus of repetitive tasks. The hype about genetic testing comes from the fact that the corporations and government have invested billions of dollars in this research. What better justification can there be for the massive expenditures than unlocking the secrets of life itself? Clearly, what has been unlocked, though, is life's enormous complexity. We have to conclude that biotechnology is not changing our human nature, if only because human nature has never been a simple expression of our genes, but the complex interplay of genetic, biological, and cultural factors. The dilemma of geneticization. The dilemma of geneticization. But if biotechnology is not changing who we are, it has impacted people's lives, particularly through geneticization of many conditions, which is the use of genetics to explain health and social problems over the possible causes. A focus on geneticization sheds light on important ethical, philosophical, and legal dilemmas raised by genetics, especially surrounding the sensitive issue of who organizes, interprets, and controls genetic information. For example, the effort to identify a genetic predisposition for carpal tunnel syndrome among railroad workers with the plan of using that information to deny them workers' compensation claims is a clear example of geneticization and the concerns it raises about who controls genetic information. It also shows how geneticization can divert attention from the social causes of the disease. Another example of geneticization concerns how biotechnologies are changing women's experiences of pregnancy, a theme that anthropologist Rena Rapp has studied at several clinics in New York City. Amniocentesis is a parental screening test for diagnosing genetic anomalies in a fetus, such as Down syndrome, a disorder arising from a defect in the DNA of certain chromosomes. Down syndrome causes intellectual impairment and certain abnormal physical features. Such anomalies become apparent in the chromosomes very early on as a fetus develops. If anomalies are detected early enough, usually in the first trimester, a woman can choose to terminate her pregnancy. Rapp's research shows that the impacts of these tests on women's lives are complex. For example, because the law protects the rights of the disabled individuals after the second trimester of pregnancy, women face a conflict between their own reproductive rights and the disability rights of the fetus. These are clearly controversial social issues that surround geneticization. In thinking like an anthropologist, the controversies over IQ testing and mother-infant bonding, we consider some genetic controversies surrounding intelligence testing to help you develop your own critical perspective on geneticization. Conclusion. The idea that human nature is biologically fixed is a powerful dogma, confirmed at virtually every turn, from medical and psychiatric fields to media headlines. But biological determinism often obscures more than it reveals, mainly because it denies the central role of culture in shaping who we are as individuals. It also minimizes the important contribution culture makes to brain development, cognitive processes, the psychological experience of self, and processes of biological evolution. Biological determinism also diverts attention away from the social causes of illness. For example, the carpal tunnel syndrome of a railroad laborer whose work compensation claim is denied on genetic grounds, even though it was his work conditions that caused his condition. But the alternative, cultural determinism, is not acceptable either, because it denies the biological factors that contribute to who we are and how we experience ourselves. Our neural pathways may be cultured in important ways, and genes may not operate in isolation, but in both cases it is impossible to deny that there are biological factors at work that play a key role in shaping our possibilities as individual humans. The biocultural approach, which emphasizes the complex interplay of culture and biology and cognition, is breathing new life into classic anthropological questions, some of which we have examined here. What is the relationship between the individual and culture? What is the role of evolution in human lives? Even more exciting is the promise for reconciling the traditional divide between nature and nurture. So what is human nature? This is perhaps the most beguiling and consequential question to the heart of anthropology. There is hardly consensus about how to characterize such a broad and abstract condition. Nevertheless, biocultural perspectives and evidence keep leading us towards the conclusion that there is no single human nature, but many human natures. Chapter 4. Linguistic Anthropology, Relating Language and Culture. In her well-known book, You Just Don't Understand, Women and Men in Conversation, Deborah Tannen describes the tensions that arise between young couples because of the different ways they use language. Consider the case of Josh, a college student who has been dating his girlfriend Linda for more than a year. One day he receives a text from his close high school friend who was coming through town. Josh invited him to spend the weekend and to go see a Red Sox play the Yankees. That evening, when Josh was over at Linda's, he told her he was going to have a house guest and wouldn't be able to see the film he had told her they would see on the day of the Sox-Yankees game. Linda became upset. Linda would never make such plans without talking about it with Josh first. In fact, she liked being able to say to her friends, "I'll have to check with Josh," because it showed how close they were. Josh's failure to check with her suggested to Linda a lack of intimacy in their relationship. Josh was equally upset by Linda's reaction, although for different reasons. When Linda asked him why he did not consult her first, he replied, "I can't say to my friend I have to ask my girlfriend for permission." For Josh, checking with Linda would make him feel subordinate to her, or worse, like a child. He felt Linda was trying to limit his freedom as an adult and as a man. Josh and Linda speak the same language, yet they were clearly talking past one another. In their case, the same words, "I'll have to check with Josh," or Linda, meant very different things to each person. What explains the miscommunication? While the expression, "women are from Venus and men are from Mars," overstates the situation, in American culture, men and women do live in somewhat different worlds. We have different expectations of each other, expectations that help shape how we use language. If Linda were more direct, people would consider her harsh, aggressive, and unladylike. Josh's directness, however, would typically be a sign of his strength, independence, and maturity. The supposed idea for a man in American culture. Taking this a step further, we can see how American patterns of gender inequality are built into how we use language and how we use language. In some settings, the workplace, say, Linda's concern for preserving good social relationships could appear as a sign of weakness, dependence, and uncertainty, limiting her ability to climb the corporate ladder. This perspective on language leads us to ask a question at the heart of anthropology's interest in language. How do the ways people talk reflect and create their cultural similarities, differences, and social positions? Embedded within this larger question are the following problems, around which this chapter is organized. Language is one of the most rule-bound and structured aspects of human culture, yet ironically, language is also one of the least conscious aspects of culture. Moreover, while language is structured, it is also one of the most dynamic aspects of human life because it can change so rapidly. Different languages have words for different sets of concepts, just as different words can be used for similar concepts. Furthermore, within a society, social hierarchies and gender differences are both marked and reinforced by linguistic expressions. Before we get into these kinds of subtleties, it is important to find out where language comes from. Where does language come from? A language is a system of communication consisting of sounds, words, and grammar. This simple definition emphasizes three features. A, language consists of sounds organized into words according to some sort of grammar. B, language is used to communicate. And C, language is systematic. But where does it come from? We can begin to answer this question in two ways. One is evolutionary, having to do with our biological heritage, and the other is historical, related to how languages have the simple fact. Evolutionary perspectives on language. Developed over time. Evolutionary perspectives on language. The simple fact that we are able to make sounds and put them into meaningful sequences suggests two different biological abilities that both link us to and separate us from non-human animals. First is the ability to make linguistic sounds using the mouth and larynx. Second is the ability to reproduce these sounds in an infinite variety of ways to produce an equally diverse range of thoughts. To what extent do we share these capabilities with other animals? There are clearly examples in which an animal appears to talk. Animal behaviorist Irene Pepperberg worked for several decades to train her famous African gray parrot, Alex, to make similar simple sentences using symbolic concepts of shape, color, and number. Alex's ability to use language was quite rudimentary compared to human speech. He was one of the few non-primates to have an obituary published in the New York Times. But do animals really talk? Call systems and gestures. Most animals cannot talk because they do not have a larynx, which enables humans to make the meaningful sounds we call language. Yet most animals use sounds, gestures, and movements of the body intended to communicate. Anthropological linguist refers to the sounds and movements as call systems, which are patterned forms of communication that express meaning. But why is this communication not language? There are 4 major reasons. 1. Animal call systems are limited in what and how much they can communicate. Calls are restricted largely to emotions or bits of information about what is currently present in the environment, while language has few limitations in the content of what kind of information it can transmit. 2. Call systems are stimuli dependent, which means an animal can only communicate in response to a real-world stimulus. Animal calls are responses to visible triggers in the external world and nothing more. In contrast, humans can talk about things that are not visible, including things and events in the past or future. 3. Among animals, each call is distinct, and these calls are never combined to produce a call with a different meaning. While the sounds in any language can be combined in limitless ways to produce new meaningful utterances, animal call systems tend to be nearly the same. 4. Animal call systems tend to be nearly the same within a species, with only minor differences between call systems used in widely separated regions. In contrast, different members of our species speak between 5,000 and 6,000 different languages, each with its own complex pattern. Humans are evolutionarily distinct from other animals in that we develop not just the biological capacity to speak through a larynx, but the brain capacity to combine sounds to create infinite symbolic meanings. Both abilities form the basis of human language. Teaching apes to use sign language. Nevertheless, it is clear that some apes have the ability to communicate beyond the limits of a call system. As researchers who have attempted to teach American Sign Language to apes demonstrate, a well-known example is a chimp named Washoe, who grew up in captivity but heard no spoken language from her human caregivers. Alan Gardner and Patrice Gardner, the Gardners instead used ASL, American Sign Language, whenever they were with her, and Washoe learned just over 100 signs that had English equivalents. Even more striking, she was able to combine as many as 5 signs to form complete, if simple, sentences. Let's see. Similarly, Penny Patterson worked with a female gorilla named Coco, who has learned to use more than 400 signs and can also combine them in short sentences. Chimpanzees and gorillas clearly have the cognitive ability to associate signs with concepts and then to combine them in original ways, comparable in some respect to the linguistic ability of a toddler. Such capabilities are not surprising among our nearest relatives. In the animal kingdom, since the human capacity for language had to begin somewhere, we would expect other advanced primates to have some limited abilities. Several anthropologists have nevertheless challenged whether apes like Washoe or Koko actually demonstrate any innate linguistic ability. These critics argue that the two apes are extremely clever and have learned to respond to the very subtle cues of their trainers, in much the way circus animals learn remarkable tricks and know when to perform them. But as linguistic anthropologist Jane Hill, 1978, has noted, most of these critics have never worked with primates. Whatever the case, such studies of ape sign language do suggest that our capacity for language may have begun to emerge with our ancestral apes, most likely from the rudimentary ability to associate meaning with signs and gestures. Full-blown language evolved as human cognitive abilities became more complex. Historical linguistics, studying language origins and change. While primatologists take the evolutionary approach to the origins of language, historical linguistics focus on how and where the language people speak today emerged. This approach uses historical analysis of long-term language change. The approach began in the 18th century as philology, which is the comparative study of ancient texts and documents. Philologist, and that is correct, philologists like the German Jacob Grimm, 1822, best known for his collections of fairy tales, observed that there were regular pattern differences from one European language to the other. To explain these patterns, he hypothesized that English, German, Latin, Greek, Slavic, and Sanskrit all come from a common ancestor. As speakers of languages became isolated from one another, perhaps because of migration and geographic isolation, the consonants in the original language shifted one way in Sanskrit, another way in Greek and Slavic languages, in a different direction in Germanic and English, and yet another way in Latin and the Romance languages, all of which came to be known as Grimm's Law. The supposed common ancestor language, which became extinct after these divergences took place, is called a proto-language. Genetic models of language change. Contemporary historical linguists call Grimm's approach genetic, since it explores how modern languages derived from an ancestral language. To identify languages that have a common ancestry, historical linguists identify cognitive words, which are words in two or more languages that may sound somewhat different today, but would have changed systematically from the same word. A speaker became isolated from one another for geographic, political, or cultural reasons. Consonants, vowels, and pronunciation diverged until they were speaking two or more new mutually unintelligible languages. For example, German, Dutch, and English are described from the same Proto-Germanic language, descend from the same Proto-Germanic language, but speakers of these three languages cannot usually understand each other unless they have studied the other language. Non-genetic models of linguistic change. Languages in contact. Languages also change by being in contact with another language, which is a non-genetic model of change. Such change generally takes place where people routinely speak more than one language. In the speech of multilingual persons, the use of one of the languages is subtly influenced by the other language's sounds, syntax, grammar, and vocabulary. Evidence of this process can be seen in the use of the flapped and trilled R in Europe, In southern parts of Western Europe, the trilled R is typical, but this pronunciation seems to have given way in the north of France to a flapped R, as is common in German and Dutch. In this process, distinctive pronunciations move across language boundaries from community to community like a wave. Now that we have some understanding about the emergence of language, we can consider how language actually works. How does language actually work? Over the past century, linguists and linguistic anthropologists have studied the majority of the world's languages and found that each is highly structured. Moreover, most people, even those who speak unwritten languages, are largely unaware of the structure of their language until someone makes a mistake. Even then, they do not always know what is wrong. They just know the sentence sounded wrong. To explain such reactions, the French linguist Ferdinand de Saussure suggested a distinction between the structure or formal rules of a language and how people usually speak it. Distinguishing language and speech allows linguists to separate the rules and expected usage of language from what people actually say. The distinction is useful because it helps us realize that the rules we use to produce the sounds, word formation, and grammar as native speakers of a language can differ from how we actually speak, which is as much a social and cultural phenomenon as it is a function of language's structure. Here we explore how language is formally structured, which is the field of descriptive linguistics, and then sociolinguistics, the field that studies the social context of language use. Descriptive linguistics, the study of langue, Langue, or the formal structure of language, is called descriptive linguistics, which refers to the systematic analysis and description of a language sound system and grammar. Linguists distinguish three types of structure in language: phonology, the structure of speech sounds; morphology, how words are formed into meaningful units; and syntax, how words are strung together to form sentences and more complex utterances such as paragraphs. And I want to repeat that. Linguists distinguish three types of structure in language. A, phonology, the structure of speech sounds; morphology, how words are formed into meaningful units; and syntax, how words are strung together to form sentences and more complex utterances such as paragraphs. High school grammar classes mostly focus on morphology and syntax. All languages have predictable phonology, morphology, and syntax structures. Phonology, sounds of language. The sound of language are organized by marking some systematic contrast between pairs of groups of sounds. The majority of both these sounds and the contrasts appear in many of the world's languages, and yet each language has its own unique pattern of sounds. When linguists listen to natural language, such as when people talk unself-consciously in ordinary conversations, they identify minimal pairs, which are pairs of words that differ only in a single sound contrast. Sound contrasts: pan, ban, and man. Consider, for example, the initial sound in the English word pan, P-A-N, ban, B-A-N, and man, M-A-N. Three sounds, P, B, and M, distinguish these three words, while the other sound in these words are the same. The consonants, P, B, and M, are formed at the front of the mouth of the lips. The difference among three consonants parallel differences among the initial sound in the word, tab, dab, and nab, or the final sounds in the word, pig, pick, and ping. These 9 contrasts distinguish 3 series of what linguists call stops, sounds that are made by an occlusion or stopping of the airstream through the oral cavity or mouth. But in addition, PDG differ from PTK in that the first group are voiced, formed by the vibration of the vocal cords or the glottis at the Adam's apple. The triplet of nasal consonants M, N, and NG are also voiced consonants that stop the airflow through the mouth, but allow the air to pass through the nasal cavity, maybe. Mind you, these are examples from English. Other languages have different sounds. One of the most distinct from other languages' point of view is the click sound of South African peoples like the Kung Bushmen. Most speakers of English, Kung, or for that matter any language, are not fully aware of how they form the different sounds they use when speaking. Yet linguists recognize that sound systems are surprisingly systematic. Dialects and accents. Another interesting way to think about phonology is to consider dialects, which are regional or social varieties of a single language, differences in vocabulary, grammar, and pronunciation, as well as regional accents such as those found in Brooklyn or Alabama and American English are examples of a fairly minor dialect variation. Sometimes the variation occurs between generations or among people of different social classes. Part of the difference between these forms of speech is intonation. The pattern of rising and falling pitch, but usually careful analysis of the sound shows that they also have systematic differences in their respective sound systems. Up to the 1970s, linguists assumed that American language was becoming increasingly homogeneous. It seemed that, owing to schools or to national broadcasts on television or radio, where the accent is standardized, regional dialects would disappear. In fact, variation in sound systems seem to be greater now than ever before. The sociolinguist William Laboff observed in the 1980s that language changed in the sound system of American English was concentrated in the cities. He also noted that sound change was most pronounced between generations in the same communities. Such findings suggest a much stronger role for peer groups in the transmission of linguistic forms than linguists have previously noticed. Morphology. Grammatical categories. The elements of grammar, tense, word order, which genders are marked, and so on, are also structured just as cultural patterns. Grammatical patterns learned during childhood feel extremely natural to native speakers in any language, even though the same forms and structures would seem quite unnatural to speakers of most other languages. A couple of examples will illustrate how varied even the most basic grammatical categories can be. Tenses. Americans tend to assume that there are only 3 natural tenses, past, present, and future. But not all languages use this same set of tenses, and some languages do not even require that tense be unambiguously marked in any particular sentence. For example, The Nigerian language of Papua New Guinea uses 5 tenses: present, future, today past, yesterday past, and a long time ago past. Even that happened earlier in the day received a different tense marking from those that happened yesterday or the day before. Similarly, events that happened several weeks, months, or years ago take a different tense marking altogether. In contrast, Indonesian has no regular tense marking in its verbs, but uses adverbs or other time references to emphasize when something has happened or will happen. Pronouns. American English has fewer pronouns than any other language. We distinguish between singular and plural, and among 3 persons: first person, second person, and third person. English also has 2 cases used when the pronoun is either the subject or the object. If we consider only person and number, we should have 6 basic pronouns plus 2 extra pronouns for gender marking in the third person singular: he, she, and it. This set of pronouns does not even begin to exhaust the possible pronoun distinctions that could be used. In French, for example, the second person singular pronoun you takes 2 forms: tu and vous, V-O-U-S, an informal and a formal form. The Awen language of Papua New Guinea has singular, dual, and plural forms of its pronouns, meaning you, one person, you, 2, TWO, and you, more than 2. Such basic examples as pronouns and tenses illustrate some of the wide range of possibilities that are possible in natural languages. Each configuration suggests certain distinctions that represent meaning encoded in a language's grammar. But such patterns do not alone create meaning. And I think that's a good place to stop because I'm losing my voice. This is 3 recordings today, and I had to re-record because I got hacked. So we'll see if this one works, and I will see you next time with sociolinguistics.